Hi everyone, good afternoon. Welcome to this session, very interesting session, coding and technology. My name is Chen Lei and I will be moderating this session. I'm a technical advisor from Vital Strategies. Very happy to join everyone in this session. And I think everyone is familiar with that protocol already. Soon I will introduce you to each of the speakers. And our speakers will speak for 10 minutes. And if there's time, we will have a Q&A session immediately after the presentation. If not, please hold your question and write it down, and we can address them at the end of this session in the Q&A session. And well, we have a small but great group of presenters. So let's start. Well, our first presenter will be Mr. Jim Kirimi from Kenya National Bureau of Statistics. He will be presenting on application of automated ICD-10 mortality coding to evaluate the quality of cause of death data in Kenya. Jim Kirimi is a statistician with the Kenya National Bureau of Statistics. His work is in the Directorate of Population and Social Scientists, Statistics, and centers on the population of vital and health statistics from both traditional and administrative sources. His current professional focus is on the digital transformation of CRVS systems in the developing countries through leveraging on emerging technologies. And our second presenter will be Ms. Sibongile Sigari from Statistics South Africa. And her topic will be automatic coding and selection of cause of death and adaptation of iris software in South Africa. Sibongile Sigari serves as the director at Statistics South Africa and has a statistical background with expertise in data operations, data processing, and validation. And our last but not the least presenter is Ms. Yukta Botharan from Tata Memorial Center. Her topic is accuracy, consistency, and timeliness of manual versus iris automated ICD-10 mortality coding in a tertiary care hospital in India. Ms. Yukta Botharas works as a project assistant at the Unit for Strengthening Cause of Death, Tata Memorial Center, under the Government of India. She has a background in public health and is currently participating in the CRVS Applied Research and Training Initiative, also known as CART. So yeah, without further ado, let's move to our first presentation. Let's welcome Mr. Jim Kirimi. Please, the floor is yours.
Okay. Thank you very much. As you've heard, my name is Jim Kirimi. I work for the Kenya National Bureau of Statistics. So today, we are looking at the application of automated ICD-10 mortality coding to evaluate the quality of causes of death in Kenya. And the year that data was availed to me was 2023. So that is what I'm focusing on. But hopefully in the future, we shall expand this to cover probably up to the year 2025. So I'd like to appreciate the two UN bodies, of course, without mentioning individuals, but my supervisor, Dr. Mosidi, my co-supervisor, Dr. Pamela, and also the people in charge of the CART program, the two Nicolas and Nicola, the Kenya CRS, who gave me the data, access to the micro data, and also my employer, the Bureau of Statistics. So, at a glance, where are we on death registration before we even talk about cause of death? Our registration completeness, and I think this was mentioned by a speaker earlier, is at 45.1%. And in this, the leading causes of death are pneumonia and cancer, and I think that has been the trend. But what is unique here is that the coding for the causes of death is done manually, and it doesn't follow the ICD-10 classification as recommended by the WHO, which makes it very, very hard to compare data for Kenya across time and leads to a lot of inconsistencies. You can't compare across countries and also across time, since there is no standard form of classification in the coding. So in this research, in addition to the, let me call them the manual CRS codes, or now they're not even codes, they're numbers. We sit here, we look at the data in Excel and say, oh, asthma, that's the first one alphabetically. Let's give it a 1. The next one is abortion, number 2, like that. So for this particular presentation, let's call them CRS manual codes. So in this study, we shall, since that data is already out and it is already published, we shall redo the same, but now with a software called Iris. Are we together? Yes. Then compare the output from Iris to the manual CRS coding and see if there are any significant discrepancies. And that is what will lead us to conclude that the data that we already published is of quality or not. So I expect this study to really benefit the government of Kenya. And as somebody mentioned yesterday, the problem is money, money, money. Much as that person is also a development partner with money. So I'll get to the recommendations. So in the research methods and analytical approach, as I mentioned, we got secondary data from the CRS for the year 2023, and it showed 205,731 registered deaths, and this covered all the 47 counties. And there are other variables that accompany those records in Excel. Which framework are we using? We are using the RAW framework of 2005, and there are key pillars in this framework. There is coverage, there is completeness, there is validity, and there is methodological consistency. In each of those pillars, you score them as either satisfactory, unsatisfactory, or unknown. And then at the end, you make a general conclusion that overall, this is satisfactory, unsatisfactory, or you don't know. We are together? The RAW framework has pillars on coverage, completeness, validity, and consistency. And for each of these, after you compare the manual CRS codes and the auto-coding from Iris, you have to determine whether you are satisfied, you are unsatisfied, or you don't know, based on the kind of discrepancies you'll see between the two outputs. And then you come up with an overall conclusion. Okay. So as I said, we have used the Iris software, and it's a bit sad because we had to get the intervention of my sister here and her colleague, who is not here, Rabelani, to assist to force the Kenyan data into their Iris dictionary. But at least it gave us some insights. And then we used data to run some frequencies to tell us more about that particular output. So these are the results. I said we had 205,731 records. And we have a cause of death for each case. We have another column that is showing the manual CRS coding stroke numbering. But now Iris produces another column which has the ICD-10 codes by WHO. So what you can see on the screen, the initial run, the green part here shows the 52% that matched in the first run. The other red was lumped as null. And you can see there were 98,720 cases. If you unpack this null, we had other causes, we had cancer, we had cardiopulmonary arrest, and we had TB. So we asked ourselves, how come cancer is being lumped as null? Null meaning uncodable. It's because Iris doesn't know what cancer is. If you're a public health practitioner and I tell you to come up with a policy targeting cancer, does that help you in any way? If I become more specific and tell you prostate, your mind will shift to men. If I tell you cervical, your mind will shift to women. So you can't just put cancer. Actually, you can see in brackets, it's cancer unspecified. So we had to do further customization by adding a few more codes down there just to cater for the description that comes with the column on the cause of death from the Kenyan data. And after that customization, this null or uncodable cases reduced to 2.1%. So based on my framework, I am satisfied with the coverage, as you can see. The completeness, we are satisfied, and completeness in this case, it means that out of the 205,731, on the cause of death, was there any case that was missing a description? There was none. Then methodological soundness, we were satisfied. One area that we were not satisfied with was the validity because of that high number of null cases. And what does that tell us? These non-specific descriptions, which actually start from the ground, that is where they say garbage in, garbage out, right? That is where the garbage starts from. A word like pneumonia, someone will write with a P, someone will write without a P, or asthma, someone writes ASTHMA, which is correct. Someone else writes ASMA. 5 minutes. Oh, that's a lot. Thank you. Yeah. So I just want you to see how serious it is, because at the end of it, we need to start from down there. Then there's the part on the dictionary being localized. I've said we forced the Kenyan data on the South African Irish dictionary. So we had to do further customization. And then even after that, we still had the 2.1%. But isn't it better if with the click of a button, you can just have 50% of the cases matched for you. And then you're left with another 50 to deal with manually. Isn't that good? Yeah. Okay. That's the whole story. So I do recommend that we automate the entire process. As a Bureau of Statistics, we have experts who are good in programming, like my colleagues back there. They can come up with a tool. And on that particular variable on causes of death, don't give those agents or whoever it is that is filling the forms the leeway to write whatever they want. Let's have a drop-down list and they just tap on the cause of death. Then we have down there other specify, which should be highly, highly discouraged. That will make our work so much easier. That is the same as the digital registration. And of course, we'll need to procure IRIS, train the CRS people on how to use it, and also train them on the ICD-10 classification. And then, as I've said, with time, based on the kind of responses we get from the field, we shall be customizing our IRIS. And I believe after a few years, we shall have a dictionary that is comprehensive enough to cover any kind of cause of death that you could ever think of. And that is it. Thanks.
Thanks, Jim, for the very interesting and detailed explanation on your slides. And now we may have time for 1 to 2 questions. The floor is open. If there's no questions, so may I throw one? So, Jim, can you elaborate a little bit more about how you improve the like rate of matching through improving your dictionary? What did you do?
Yeah, as I mentioned earlier, IRIS, well, in my earlier slides, we said cancer has been the second leading cause of death over the years. But IRIS, now that cancer being the second leading cause is an output from the manual CRS coding, not IRIS. So when you subject the raw data again to IRIS, IRIS doesn't recognize cancer. It has to be a specific type of cancer. So we introduced those cancers as additional codes, right? Then we have the cases of the cardiopulmonary arrest, blah, blah, blah. Those kind of wordings are not in the South African dictionary. So we introduced them down there, and that is how they ended up being given a code. And that is how the 48% reduced to 2.1%. And as I've suggested, if we shall ever procure our own IRIS, then we need to customize it to the Kenyan needs. Because here we were forcing Kenyan data on a dictionary that is not Kenyan. Yeah.
Thank you. So do we have other questions? If not, may we go to the second presenter, Ms. Sipomjel Sekering from Statistics South Africa, please.
Good afternoon, everyone. I would like to start by acknowledging my co-author, Rabelani Shandugani, whom she couldn't make it due to unforeseen circumstances, but she's with us online. And I would also like to acknowledge the input and advice that we received from ECA and SCAP. And I will extend my gratitude to my supervisors, Lillian Sibisa and Dr. Musidin Sapo. and not forgetting the famous Nicholas. We all know that mortality statistics, the backbone of public health. It tells us what people are dying from, and that knowledge guides the interventions, informs resource allocation, and help us track progress towards national and global health priorities, including the Sustainable Development Goals. Hence said that, but in South Africa, we face a challenge of coding of causes of death manually, taking more than 18 months, which delays the publications of mortality statistics to assist the policymakers. And hence this made us to study, to explore whether automation can change this picture. And our aim was to evaluate iris accuracy, consistency, and the timeliness of it compared to manual coding. This study used the quantitative design to compare manual mortality coding with the iris automated system. And we analyzed a shared data set of death certificates that were coded manually by trained mortality coders and auto decoding by iris system. The data that we received, that we used were for 2020 data set. Our sample was approximately of 400,000 records of 2020, and we used the systematic random and stratified sampling. And we had to clean, to remove the duplicates and standardize the formats, remove the incomplete records, and exclude those that do not have the diagnosis or anomalies that were outside 2020, which those that did not have the death year. And by processing, we auto the 2020 dataset, and it applied the rules in IRIS and gave the ICD-10 codes and also the rejection flags. Then after we meshed the outputs from the automated dataset with the manual dataset that was already been coded. This is the results, some of the results that we received from the auto coding. I will start by the rejections and why were those records rejected. As you can all see there, that 79.5% of the rejections were due to the code, meaning that IRIS could not able to give the code for those records. And the 13.7% was from the entity reference numbers, which is the language independent identifier used by mortality medical data system to identify causes of death. And the list of the rejections were from the syntax, where IRIS will read the format of the parts where the medical practitioners will write the diagnosis for the deceased. And from the status of the auto coding, 72% were coded successfully, and the rejected were it was 28%, which consists of the reasons that I've alluded earlier. Those reasons, they are for this 28%. Yeah, as much as we have the 72% coded successfully, we do acknowledge that there's a proportion of death certificates that still needs an additional review. And these are the results when we're comparing the manual and the auto-coded dataset. And as you can see that when it was the 3-digit level, 80% was successfully coded. And on the 2-digit level, 82% was coded, meshed with the manual coded. And 87%, which is at 1-digit level, meshed, which represent the chapter in which the codes assigned belong to. So in overall, there is moderate agreement between the two approaches. However, there is discrepancies that we observed in certain course categories. We did observe that there was high IRIS ICD-10 coding index of the proportion of 0.849, which reflects the strong performance in dictionary and terminology matching and recognition of medical concepts. And we observed moderate IRIS performance index of the proportion of 0.7216 that indicates reduced accuracy when determining the underlying cause of death. And there is an ongoing need to strengthen the accuracy and reliability of causes of death because we want the IRIS performance index to improve from where it is now. And when we're comparing the auto with the manual coded, there was a high agreement for cardiovascular diseases, respiratory disease, renal failure, influenza, and pneumonia, and ill-defined conditions. But then there was the lower agreement for COVID-19, other infectious disease, neoplasms, endocrine disorders, congenital anomalies, digestive diseases, and maternal causes. And very low comparability in pregnancy-related deaths and some digestive chapters, which this was introduced by having multiple comorbidities and incomplete certifications. Our next steps and the recommendation is that we need to expand and update the IRIS dictionary to better capture the local terminology, abbreviations, and evolving disease descriptions. And we need to enhance the rule-basic logic for those complex causal chains that contributed in the rejection of ECME, and to improve the death certifications quality, and also support the transition to ICD-11 and digital tools. And we also want to expand the research scope to include the multiple year data to assess the trends, stability, and the impact of evolving certification, as we only focused on the year 2020. I thank you.
Thanks, Sigrid. And now the floor is open for questions. It's after the lunch, so we may need some time to wake up, but I know there are some experts and people with rich experience in using Iris and well, probably Doris too, in this room. So yeah, if you have questions or comments, yeah, please feel free to give it now, or if you want, you can hold it for the Q&A section. All right, so let me give one question. And I'm wondering Your iris automated coded result is compared with the manual coded result, and have you validated the accuracy of the manual data set, manually coded data set? I saw you this data cleaning, but in terms of accuracy, whether there's like well validation by probably another coder.
Yes, we did check the accuracy of the manual coded already before we even started with the auto coding. Yes, we did implement, there is some rules implemented for the manual coding. Our coders, they do use iris, but just for manual, not the auto. They do code manually using iris. Yes.
Are there
And-
other questions?
And we also have the Anacode. We use Anacode and Code Edit. Yeah.
Data quality.
Yeah, for data quality, yes.
Do we have other questions? Not, we can keep all the questions for the Q&A section. Then we move to the third presenter, Ms. Yukuta. Please.
A very good afternoon to everyone present here. I am Yukta Bothra. I am from India, working under Tata Memorial Center. Firstly, I would like to acknowledge and give my gratitude to Tata Memorial Center for letting me conduct this study in the institute, extending my acknowledgement to the CART initiative, ESCAP, and a special thanks to Nicholas, Joanne, and Petra for their continuous support and guidance. Reliability of the mortality statistics is very crucial, as this is the only mortality statistics which is used for public health, medical research, evaluating interventions, setting health priorities, setting health policies, health planning, resource allocation, all has been done based on the mortality statistics. The underlying cause of death, which is the disease or the injury that has initiated the chain of event leading to death, is the most important aspect of the medical certification of cause of death. So the medical certification of cause of death is filled by the physician after a death has occurred in a hospital or outside the hospital. That's a non-institutional death. WHO has set us few guidelines and rules which based on which the selection of the underlying cause of death should be done for each of the MCCD form which is filled by the physician. Speaking about the national data of the India, this report is the data has been taken from a MCCD report, Medical Certification of Cause of Death report for 2023 by Registrar General of India. If we look into this, the report says the total number of registered deaths by total and also a total number of medically certified deaths and a percentage of that. India is like other many countries where the source of cause of death is MCCD. And if here we can see it's 22% of the registered deaths have the medical certification of cause of death. This 22% is the only data which has been used in India to circulate, to plan the health policy, health making, all the research, the interventions related to the health are all based on this 22% of the data which is being given for the year 2023. But if we look into the trend of years, this is almost a similar sort of percentage which we are receiving from the sequence of year. Why a comparison study? A comparison study as based on the literature review and the researches I have been gone through, the manual coding is always associated with a high workload for the coders and can result in the error and inconsistent data. My research methodology is a mixed method study where I'll be taking all the MCCD forms which are registered during a time period of June 2023 to June 2025. And this research I've broadly classified in a three-step process. Before that, I would like to explain why I have chosen iris as the comparative part for the manual coding. According to till 2024, iris has been already till 2024, iris was already been implemented in 25 of the countries, where they have fully shifted and implemented iris as their only mortality cause of death source. And during that 2024, three countries were in the process of implementing iris. So I am assuming in 2026, there are 25 plus more countries which have fully implemented iris as their automated software for the mortality data. Looking back into the research methodology, the research methodology is a comparison between a manual coding method and an iris automated coding method. The research will be conducted in a mixed method study, where the first part is knowing the manual coding quality assessment. The A brief about the methodology before that. A group of coders will be divided into two groups, where one group will be doing the manual coding and the second group will be doing the iris automated software coding. Before dividing this, both of the groups inclusion and exclusion criteria will be there. In the manual coding, the coders representing the manual coding method will should be aware and should be with the knowledge of knowing the decision tables. These decision tables are given for the coders to know them, how to do the know the causal relationship between the conditions which the physicians have filled. So a manual coder group should be aware and should have the knowledge of all the decision tables, how the decision table works, because this is based on the WHO guidelines. Coming to the Iris group will be given a formal workshop training where they will cover the understanding of different operations of Iris, the use of Iris in both text only and the code only mode, the use of program to how to transfer the MCCD form into the Iris database, and also they will be trained to accept success to the different types of errors which the Iris will be giving, how to overcome the errors. These are two groups which will be divided, the manual one and the iris one. Once the manual coding has been done by the manual group of coders, the assessment of the manual coding which the coders have done will be taken, and the assessment will be done based on the ICD-10 mortality coding quality assessment software tool, which is developed by Bloomberg University and University of Melbourne. This tool will give us the outcome of the quality of ICD-10 mortality quality, which is how the manual coders coding has been given. This quality will give us a outcome base of good, poor, excellent. And then moving to the iris coding quality, the second group will be doing the same MCCD form which the manual coders have done. Iris coders will also do the same MCCD form but using an iris software. After that, the line codes, the FUCOD, which is the final underlying cause of death for each MCCD form, will be compared, and this will give us the accuracy and the timeliness and the consistency of the data. Moving to the most crucial part of the study will also be looking into the challenges and the barriers which the coder will be facing while using both of the techniques. So this challenges and barriers will give us a perspective and the overall experience of the coder, and will also give us a suggestive coding method which is better to be adopted. I have also given some variables I have presented some variables which will be looked into while the qualitative part of the study has been seen. These variables will be missing codes, the number of correct codes, the correct FUCOD, and all the codes correct. Based on these variables, the quality outcome will be given. This quality outcome is based on the tool which has been designed by University of Melbourne and the Bloomberg philanthropists. The score I'll just explain in a short the scoring is totality of the codes will reflect 25% of the score. The accuracy of the individual cause of death codes, that means the codes and the conditions which the physician have filled in the part A and part B will have 25% of the score. And the final and the most important part is the accuracy of the final underlying cause of death. This will contribute to 50% of the scoring. Based on the scoring, this outcome quality will be seen of every MCCD form which the manual coders have coded will be given in terms of poor, moderate, good, very good, and excellent. Moving into the qualitative part of the study, the qualitative part of the study will, it's a semi-structured questionnaire which is designed, which will look into the insights of the better coding technique, the barriers and challenges faced by the coders, the timeliness, the coders' knowledge and skill, productivity, and workflow. As this study is under IEC, the data collection is yet not begin, and as we talk, the IEC is already shared the questions regarding regarding the queries. They have shared the questions, and after this research form, we will be working on that, and the IEC submission will be completed. But still, I am expecting some outcomes. The study will give us a comparison of two coding methods, which will be spoken in terms of accuracy, consistency, and timeliness. The consistency will be measured calculating the cause specific mortality fraction, where each for each 3 years the consistency of the data will be looked into, and based on that, in this demographic detail will also be there. The more of a detail or more of a data will be abstracted if we are looking into the age and sex of the age and sex is also taken into. Then there will be the conditions, the top 20 cause of death based on age and based on sex will also be uh, taken up from the study. Also, the final FUCOD, the final underlying cause of death for the manual coding, and with it will be for compared with the automated coding, will be also give us a very brief idea about how accurate the mortality data of a country is. These findings will support the national adoption of the superior method for the effective health policy and decision making. The study is under IEC, but still there are some recommendations. I assume the study will support the adoption of the most accurate and reliable coding method, and this will also provide evidence for government for the better decision making in terms of health policy, health planning, intervention planning. A small expected timeline, which how the study will go in the next 6 months. The IC will be done in like 15 minutes, 15 days, and data collection and the data analysis will take around 2 months to be completed, following with the manuscript writing, which will take 2 months again. So we are targeting to complete this in the next 6 months for the publication. I am very thankful for everyone for listening this. Thank you. I would like to end it by every birth is to be registered and every death should be know the cause of death. Thank you.
Thank you very much, um, Miss Yukta. So, do we have immediate question for Miss Yukta?
Yes.
Yes, please. Yeah, please.
Uh, Thanks to all of you for your nice presentation, and you all are working or going to be work with that Irish coding I mean software. I was just wondering if uh, Yukta is going to do that, but if there is any weakness or flaw you found in Irish software in your version or in your country, maybe. Thanks for that.
Okay. I believe there can be a challenge in Iris if there is not a proper dictionary developed in terms of the country. So the challenge will be using a correct dictionary which is developed for a specific country. So developing a dictionary would be a challenge, but once that is done, Iris will be very useful.
And just to add on it, besides the dictionary, also the diagnosis. If the diagnoses are written in a different language, you need to update the iris to accommodate the languages in your country. And also work on it also has challenges when there's a complicated or multiple cause diagnosis. So from what we picked up on the rejections, that he couldn't code, if there is too complicated that it needs that those cases, they need a manual intervention. So maybe if in future they can work on the complexity of it. Thank you.
Yeah, and also remember, we suggested if we could have another software primarily for collecting data that limits the person doing the data entry from typing whatever it is they think is the description. There is a preloaded drop-down list where they tap on the cause of death. And then in a worst case scenario, we have an option for other specify. That would really help. Yes.
Thanks for that comments. So yeah, Maya, you have comments or question, please?
Yeah, thank you for the presentation. And as we are speaking of the timeliness also, have you considered of the checking the feasibility of batch processing of the iris coding also? Because yeah, if so, the time can be reduced, but I know there are issues with the accuracy. But have you thought of doing checking the possibility of batch processing also? Thanks.
In South Africa, that's how we were doing it in batches, all the certificates. We use the batch processing. Thanks.
Thank you. Thank you to the moderator. Particularly, I am Rafiul Hassan, and I am from the Ministry of Health. I'm a field epidemiologist. As I am from the epidemiology background, so I usually like to focus on the methodology particularly. I know Yokta is very young, and she is very known to me also, but my question is to her. That you are telling your research title is Accuracy, Consistency, and Timeliness of Manual versus IRIS Automated ICD-10 Mortality Coding in a tertiary care hospital in India. And you have showed that you are using a mixed method study, which has 3 phases. And we can say this is intervening type. First, you are doing qualitative, then quantitative, then again qualitative, right? First, you are going to continue a qualitative phase, then quantitative phase for comparison, and finally, again qualitative phase for exploring the reasons.
If we make it simpler, it is first part will be the quantitative part where the comparison will be done, and the second part will be the qualitative part where the semi-structured questionnaire will be provided to the coders for getting their perspective.
Okay, thank you so much. Okay, just hear my question.
Yes.
That you are, however you present and you have written, I have a little bit confused, nothing else. Okay, that is you are the iris system is already present, already implemented in your hospital, or it is going to be implemented.
No,
So you will implement for your study.
yes.
So I will just want to rectify a little bit.
Implement if the result is supporting which coding method, then the implementation will take time.
Okay, that means you will do a piloting, something like that. Okay, so it will be very much helpful if you write that this is an interventional study, because you are providing an intervention. You are providing a group that Irish will work with. One group will work with Irish, and another group will not work with Irish. So this is an intervention, and it will be very helpful if you mention this in your presentation, in your paper. Thank you so much.
Thank you for the comment. I'll look into this. Thank you.
Yes, please.
Thank you. Thanks for the presentations. I think my question goes to Victor. I saw in the initial slide you indicated, I suppose this is national, 8 million deaths. Are there 8 million deaths registered?
Yes.
I just want to finish my question, then you can. So of these, you say 5 million, I think, are reported on the MCCD form, and then you have around 1 million that are certified nationally. Is that nationally?
Yes.
So I was just interested in what is your sample for the hospital, your study, given the scenario. But I'm also wondering, because your study setting is a hospital, what proportion occur at home in the community in India? I just want to have an idea what proportion you'll be talking about in your study, and also I wonder if you in your layout, when you come to the second phase, are you considering the effect of the experience of your coders, the two groups, and how are you going to handle that? Thanks.
Okay. The sample size, first I'll clear the sample size. So the hospital which I am been the study has been conducted is in a tertiary care hospital, which has approximately around, if I consider 500 deaths per year, and I'm taking a sample of 3 years, so it will be around 1200 to 1500 of the sample size. The study is under IC, that is why I am unable to put a number of the sample size. And then coming to the qualitative part, where the coders will be divided into two parts, that is iris and the manual coding, and approximately 10 coders will be there, which will be divided into two groups, five each. So does this answer the question? Yes. Thank you.
Follow-up questions?
Okay, thank you. My question is to Sibongile. Do you have a specific reason why your research was done for only 1 year, and why 2020? Given that there were high cases of COVID-19 in 2020, and from your results, there is a low agreement with COVID-19. You do not have to answer, but it's something for you to consider. And I'd like to suggest that you can add strength and rigor to your research findings by adding another 2 years, at least one before 2020 and probably another after, just for your consideration. Thank you. It was a good presentation, though.
Yeah, thank you. Yes, as when I was concluding, I did say that we need to include other years before and after the 2020. And why we went with 2020, it's because it's the year that the diagnoses were already being captured from key form image. As before then, the other years, they were being used by the coders while they were coding underlying cause of death. So we chose it because of that. And yes, you are very right. We'll have to do that trend. Thank you very much.
Thanks for the suggestion. Do we have other comments or questions? All right, so may I throw one question to all the panelists? So we are saying like technology is changing our life, right? And here we are trying to find the right technology to make the CRVS people's life easier, right? So in terms of the benefit of using the automated tool, do you think from the researcher's perspective, there's a way to quantify the benefit in terms of reduction in human resource or any other like government budget input needed? And do you think it's possible to incorporate into your research?
Thank you very much for that question. And as for our country, the manual coding was taking long, so we are very delayed. If you can check our publications, we still behind because of that. And we realize that using the auto coding reduces the number of months that to use, and we also have a shortage of coders. Yes, so instead of hiring more, then this comes in to assist on that. Thank you.
It's it's something I'd actually dreamt about. Yeah, because I was asking myself, Iris, there is a cost implication of the software, the licensing, the training, vis-a-vis this other system of where you have to put people together, maybe not as many as the ones who are using Iris. So yeah, probably that would be a good area either to incorporate in these studies of ours, or it could be a challenge that we could throw even to the members here to do a CBA, a cost benefit analysis of that. I think it's something that would really add value. Yeah.
I just want to add in this. Even though Iris can be implemented and the country can run totally on a software, an automated software, but still there will be requirement of humans, as the humans will be trained how to successfully reject the errors, because Iris will definitely give some errors, and there will be a list of errors where the different approach will be required to solve the error. So a human requirement will always be constant. Thank you.
Very good point. Thank you. Yeah. As a technology advance, well, our experts, human resources, coders, physicians will remain to be very important. Thanks. So online? Uh-huh. Okay. No, I mean the question on chat.
No, it's not up on this one. Are there any questions in the Teams chat, Ampon? Can you see? No questions online? Thank you.
Okay, thank you. So we then uh, then we would like to thank the wonderful presenters. We had Jim and Sibongil. I hope that this time I got your name correctly. And Yokta presenting to us the very interesting studies they conducted or being conducted. Jim emphasized the very important usability of using Iris to code or assign an ICD code to the cause of death, right? And through the customization of the dictionary, the matching rate or the success rate improved from less than half to more than 90%. That's impressive. And our second presenter gave us a very good study presentation about the comparison between the automated tool and the manual coding. I think that this will be something every country can learn from, because that different dictionary you use may give you different results, and it's important to conduct the local validation, and that the findings from the study from South Africa will be very useful for others to learn from and consider as a reference. And lastly, but finally, but not the lastly, we have Yokota planning a new research similar to the South Africa research, but adding more elements in terms of qualitative study to explore deeper the reason, the gaps, the possible facilitators to, further improve the use of the software in the country. And with that, my main takeaway is IRIS is useful, and there's a chance it may become our dream tool. And it needs customization, adaptation, especially the local dictionary. And in the future, the human resources, the experts, our coders, our physicians will remain to be very important resources, and we need training and resources to support them. Okay, with that, I would like to thank the audience also, including those online. And with that, I would like to close the session, and thank you again. Hope you enjoy the rest of the research forum. Thank you.